Okay, in this section we're going to be writing conics in polar form, and we're going to be changing from polar to rectangular and so on and so forth. So let's make sure that we remember what we talked about last lesson. The first section says classify the conic with the given eccentricity and directrix. Then write the equation of the conic in polar form. So first off, the eccentricity, let's remember that anytime we have an eccentricity of 3, that this is going to be a hyperbola. So let me write that right here. And let's go ahead and write the basic form. If our directrix is x equals 1, so our directrix is to the right of our pole. So here's going to be the basic form of that conic section. And let's remember what everything means. K is the distance from the pole to that directrix. On the bottom, on top and bottom, our E is our eccentricity. So all we have to do is first off, let's replace all the E's with 3's. And then we look and see that we are to the right one spot on our directrix. So therefore, let's replace the K with 1. 1 times 3 is 3. So therefore, there is your equation in polar form. Second one, an eccentricity of 0.9, 0.9. Here we're going to have an ellipse because of that eccentricity. Our directrix, y equals -2, is down 2 spots, so it's below the pole. So here's going to be your form. So again, I forgot to put that this is an ellipse. So let's replace all of our e's with 0.9s. So 0.9 sine theta, and replace all your k's with the distance to this directrix, which is 2. Do not use the negative, use the distance. So 2 times 0.9 on top will give you a 1.8. So there's your equation. And then number 3, let me zoom in a little bit more. An eccentricity of 1, so this would be a parabola. Your directrix is to the left of your pole, so therefore here is the basic form of that equation. Again, we simply have to replace all of our e's with 1's. So you have 1 cosine theta on top, and you have k times 1 on, 1 times cosine theta on bottom, k times 1 on top. The distance to our directrix is 6, so therefore 6 times 1 on top will be a 6, and there will be your equation. So it'll be 1 minus simply the cosine of theta. Okay, in the next section, we're going to be changing from polar to rectangular forms. Now here, let's recall that x is the same thing as r times cosine theta because cosine of theta is x over r. Same thing for sine is y over r, so therefore y is r sine theta. And then by the Pythagorean theorem, x squared plus y squared will always equal r squared. So let's go ahead and see if we can change these. So here's the first thing that I would do. Well, let's first identify. It says classify the conic. So let's check our eccentricity. Again, our eccentricity, this is in basic form. Our eccentricity is in front of this cosine theta, so it is a 1. So therefore, this should be a parabola whenever we change it. Let me zoom in a little bit more. So now let's change it. Here's what you can do. Go ahead and move this bottom up to the other side by multiplying. And I'm going to distribute by that r when I do that. I'm going to get r minus r cosine theta, which looks familiar, is equal to 4. Now, anytime you have an r cosine theta or an r sine theta, again, we can use this over here and we can replace that. So I now have r minus x is equal to 4. So we've got to figure out some way to replace that r. Here's the best method of doing it. If we can turn it into an r squared, we can get rid of it. So what I'm going to do, I'm going to isolate it by moving that x back over. So I have r is equal to x plus 4. And to turn that into an r squared, I'm going to square both sides. The biggest thing to remember, though, when you square the side, you do have to FOIL. So the left side turns into r squared. The right side turns into x squared plus 8x plus 16. To square a binomial, square the first, multiply them and double them, and square the second one. And now I can change it. R squared can now be replaced with x squared plus y squared, and my equation now looks like this. X squared plus y squared is equal to x squared plus 8x plus 16. Combining like terms, you can get rid of the x squareds by moving them to the same side, and you're left with y squared is equal to 8x plus 16. Let me try that again. 8x plus 16. And let's go ahead and get that in our standard form for a parabola. I'm going to go ahead and isolate my x. I'm going to move a 16 over first. So I have now y squared minus 16 is equal to 8x. I'm going to divide both terms by 8. The way that I'm going to do that is by multiplying by 1/8, and then I'll divide that by 8, and I get x is equal to 1/8 y squared minus 2. That is your standard form. The next one's going to follow kind of along the same lines. Let's go ahead and distribute that 1 plus sine theta, and I now have r plus r sine theta is equal to 14, and we follow pretty much the same steps, except for r sine theta is equal to y. So I now have r plus y is equal to 14. Let's move our y over, and I have r equals, I'm going to write that as 14 minus y. Let's square both sides so we can turn this into an r squared, and you have r squared is equal to square this, we do have to FOIL. 14 times 14 is 196. Multiply them together and double it is negative 28y, and then plus y squared. Anytime you have r squared, you can now replace that with x squared plus y squared to get rid of all your r's. And that's equal to 196 minus 28y plus y squared. And kind of the same thing happens here, except for your y squareds cancel. So you're left with x squared equals 196 minus 28y. Now let's turn that into our basic form. Let's move our 196 over, and I have x squared minus 196 is equal to negative 28y. Let's divide each term by negative 28. So I have negative 128 x squared. When you divide this by negative 28, that's going to turn it into a plus 7, and that's equal to y, and I'm just going to leave it like that. Y equals negative 128 x squared plus 7. The next one, doing the same thing. Distribute your r, gives you r plus r cosine theta is equal to 2.5. R cosine theta can be replaced with an x is equal to 2.5. Let's move our x value over, and it gives me r is equal to 2.5 minus x. Follow the same steps by squaring each side. Gives me r squared equals 6.25 minus 5x plus x squared. You can now replace r squared with x squared plus y squared equals 6.25 minus 5x plus x squared. Cancel your x squareds. Let's go ahead and get this in standard form. Move your 6.25 over. Gives you y squared minus 6.25 equals negative 5x. To isolate x, let's divide each of these by negative 5, and I now have negative 1/5 y squared plus 1.25, and that will equal, I'm going to put my x first. And I've quit labeling these, but each and every one of these are parabolas, because again, my eccentricity was 1 here, my eccentricity was 1 here, and my eccentricity here, though, you would have to factor the 3 out and divide, but you are going to have, if you do that, still going to have an eccentricity of 1, so this will be a parabola as well. So let's go ahead and distribute again. That's going to be 3r minus 3r sine theta is equal to 30. Now, I don't like all those 3's. Everything's divisible by 3, so you can actually go through and divide everything by 3, and that will equal 10 then. My r sine theta, again, you can replace with y. So you have r minus y is equal to 10. So therefore, r is equal to y plus 10. So therefore, square both sides. R squared would be y squared plus 20y plus 100. Let's replace r squared with x squared plus y squared equals y squared plus 20y plus 100. The y squareds will cancel. Let's move our 100 over, and it gives you x squared minus 100 equals 20y. Divide everything by 20, and you now have 1/20 x squared minus 5 is equal to y, and there is your parabola. Okay, the next one. Let's check this one because I believe we might have something different here. Our eccentricity right here is going to be 0.5, so this should be an ellipse. The conversion, though, is going to be the exact same thing. Multiply everything by the bottom. Gives you r minus 0.5, and I'm actually going to replace that with 1/2 just because it's easier to work with. 1/2 r sine theta is equal to 3. Same thing, r sine theta, we're going to replace with y. So you have r minus 1/2 y is equal to 3. Let's isolate our r so we can square it. So r is equal to 1/2 y plus 3. Square both sides gives me r squared equals 1/4 y squared. Multiply them and double it. That's going to be 3/2 plus 3/2 will be 3y plus 9. We're again going to replace our r squared with x squared plus y squared. So you now have x squared plus y squared equals 1/4 y squared. And now on every other problem, those y squareds canceled. Here, however, the y squareds are going to stick around, which is what's going to force it to be an ellipse or something different than a parabola. So let's move our x squareds and y squareds all to the same side. So like we would if we were trying to get it in standard form. So you have x squared, no more x's. Let's move our 1/4 y squared over and subtract it. So you will now have 3/4 y squareds. Let's go ahead and move our 3y over. And then you have is equal to 9. Now, I'm really not a big fan of this 3/4 being here, so you've got a few options. Now, if it was a 0.75, you could go ahead and factor that out and all that. However, there's a really good way of getting rid of fractions. Let's take everything, every term, and multiply it by the common denominator, which is 4. And it's going to remove all fractions, so it's easier to work with. So you have now 4x squared. This will now be a 3y squared. This will be now a negative 12y is equal to 36. So you have no more fractions. So now let's 4x squared. Let's factor out this 3 so that we can complete the square. You're left with y squared minus 4y, leave a space, is equal to 36. When you complete the square, you're going to half and square, add 4 there, so you add 12 to the other side. So you now have 4x squared plus 3 times y minus 2 is what that factors into squared is equal to 48. Then our last step, since this is an ellipse, you're going to take all 3 terms and divide them by 48 so that you have equals 1 on the right side. 4 over 48 reduces to 12. 3 over 48 reduces to 1 and 16. And then 48 over 48 is 1. So my ellipse is now x squared over 12 plus y minus 2 squared over 16 is equal to 1. That is your ellipse. Next one, doing the same thing. Distribute your r to get rid of that fraction, and that gives you r plus 1.5 r cosine theta is equal to 5, which, by the way, here is your eccentricity of 1.5. This should be a hyperbola since it's greater than 1. R cosine thetas are replaced with x's, so you have 1.5x. Do the same thing we have on all of them. Let's isolate our r by moving the 1.5x over. So you have 5 minus 1.5x. Square both sides gives you r squared is equal to 25 minus 15x plus 2.25x squared. We can now replace r squared with x squared plus y squared equals the same. Let's get all of our x squareds and y squareds, all of our variable stuff on the same side. Let's go ahead and move them to the left. So therefore, we're going to subtract this, and that gives me negative 1.25 x squared. Move your 15 over by doing plus 15x. Leave a space. You have plus y squared over there, and that is equal to 25. Again, I'm not a big fan of the negative 1.25 out front, so you could multiply everything by 100 if you wanted to, move that decimal over, and it turns it into a 125, and then you could reduce some stuff. However, I am going to work it with it. I'm simply going to factor out the negative 1.25. You're left with an x squared. Then you've got to figure out negative 1.25 times what gives you negative 15. And you just do so by simply dividing it, and you get 12. So you have minus 12x, leave a space, plus y squared equals 25. Let's complete our square. Half it, square it, gives you 36. So on the other side, I'm going to add whatever you get when you multiply negative 1.25 times 36, which is a negative 45. So let's go ahead and factor now. I have negative 1.25. Factor this, that's going to be x minus 6 to the second power plus y squared is equal to a negative 20. Next step, I've got to go through and divide everything by the negative 20. And we see now why I'm not a big fan of that 1.25. So let's talk about what we can do there. Negative 1.25 over negative 20. So 1.25 over 20. We can go ahead and move our decimal over on top by multiplying by 100. That'll be 125 over, move it over twice on the bottom, and that's going to be 2,000. When you reduce that, you can divide top and bottom by 25. That'll be a 5 on top and an 80 on bottom. That reduces to a 1 and a 16. Therefore, a negative over a negative, that reduces to 1 and 16, which cleans up pretty nice. So you have on top, x minus 6 to the second, on bottom a 16. The second one, you have a positive divided by a negative, which would be a minus y squared over 20 is equal to 1. There is your hyperbola. I do want to remind you, you've got to make sure that your second term is the negative term of that hyperbola. If the first term had been negative, you would have had to flip-flop those. Number 10 has an eccentricity of 0.9, so therefore this should be an ellipse. Let's follow the exact same steps. First off, by distributing your r. So you have r minus 0.9 r cosine theta is equal to 3.8. We're going to replace the r cosine theta again with x is equal to 3.8. And again, if you would like to, all these decimals, if you want to multiply by 10 to get rid of them, that is perfectly fine. I'm going to move the 0.9x over, and that gives you r is equal to 0.9x plus 3.8. Square both sides. Now, here's where it gets a little fishy. That's going to be a 0.81x squared. Multiply the two together and double it. Gives you plus 6.84x, and then square the 3.8 and you get 14.44. Again, we replace r squared with x squared plus y squared is equal to the exact same thing. Let's go ahead and combine all of our x squared stuff. Move this over, you're left with 0.19x squared. Move the 6.84x over by subtracting, so you have minus 6.84x. I'm going to leave a space right there just to remind me that I've got to complete that square, and that will equal 14.44. And again, this is where that shortcut comes in handy. We don't like all these decimals, so why not multiply everything by 100? So instead of 0.19, you have 19. Instead of 6.84, you have 684. You do have to multiply this by 100 as well. Don't forget it. And instead of 14.44, you have 1,444. It just looks much better. So let's factor out our 19 in our first couple of terms. You're left with x squared minus 36x. That worked out really nice. And then you still have plus your 100 y squared equals 1444. Let's complete our square. So we're going to half our 36. You get 18. Square it, and you get 324. However, we've got to add to the other side 19 times 324, which is 6,156. So let's go ahead and now factor that. That's going to be 19 times x minus 18 squared plus 100 y squared is equal to 7,600. So now our last step, we've just got to simply go through and divide everything by 7,600. Let me write that right here. Divided by 7,600 and divided by 7,600. 19 and 7,600 reduce, and it goes into it 400 times. 100 and 7,600 reduces and then turns it into 76, and this turns into 1. So my equation is now x minus 18 squared over 400 plus, and you see that it is an ellipse because of that plus, y squared over 76 is equal to 1. There is your ellipse. Okay, the last one, number 11. Start out the exact same way. Let's look at our eccentricity first. I'm going to clean this up just a little bit. So you have r is equal to 2 over. You've got to factor this out, and it gives you 0.25 times 1 plus 3 sine theta. 0.25, if you write that as 1/4, it cleans up a whole lot better, because to get rid of that 1/4, we're going to multiply top and bottom by a 4 instead. So that gives you 8 on top and 1 plus 3 sine theta on bottom. So I have an eccentricity of 3, so therefore this should be a hyperbola. Now, which one of these do you use to actually turn it? It doesn't matter, but this seems a whole lot cleaner. I would use it to change to rectangular coordinates. So let's go ahead, distribute the bottom. That gives you r plus 3r sine theta is equal to 8. R sine theta, again, is replaced with y, is equal to 8. Move your 3y over, it gives you r equals 8 minus 3y. Square both sides, gives you r squared equals 64 minus 48y plus 9y squared. Replace r squared with x squared plus y squared is equal to 64 minus 48y plus 9y squared. Let's move all of our variables to one side and our constants to the other side. So I believe I'll move them all to the right side, actually, since I have the 9y squared over there. When I move the 1y squared, I now have 8y squared. You already have the minus 48y over there. When I move my x squared over there, it becomes a minus x squared. And then when I move my 64 to the other side, it becomes a negative 64. And I believe that is correct. Anytime you have something in front of the y squared, you do have to factor it. So you have y squared minus 6y left, and then the minus x squared. Let's go ahead and complete that square by adding a 9. To the other side, you have to add 8 times 9, which is 72. 72 minus 64, you now have 8 equals 8 times y minus 3 squared minus x squared. And it actually worked out really good that I wrote my y stuff first, because now I've got to go through and I've got to divide every term by 8. And it just so happens that my minus term, since this is a hyperbola, ended up being on the x squared. So I had to write that x squared second anyway. So this reduces. 8 over 8 turns into a 1. So I have now y minus 3 to the second power over 1. And you don't have to put that 1 if you don't want to. Minus x squared over 8 is equal to 8 over 8, which is 1.